Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be jumping into chapter number 11. We are almost done. This is amazing. There's only 2 chapters left. You can do it. All right, chapter number 11. Chapter number 11 is pretty tough. I don't know that it's the hardest chapter in the book, but it's a tough chapter, so you better be paying attention here. Some of you don't like fractions. Well, I have bad news for you. Chapter 11 is all about fractions. So let's jump into it. Let's see what the book has to offer here. If you will go ahead and look down at page number 406. That's where chapter 11 starts. And the first thing I want to talk about, it's right here on the screen too, rational expressions. Here's what a rational expression is. A rational expression is a fraction in algebra. So in other words, fractions whose numerator or denominator, or both numerator and denominator, are composed of polynomials or contain polynomials. In other words, fractions with x's, fractions with binomials, fractions with x plus 3, things like that. That is what we're talking about when we talk about rational expressions, okay? This chapter basically goes through and talks about how to do all kinds of different things with those. One thing that you have to keep in mind as we go through this, and it's right there on page 406, is you have to keep in mind that it's on table A, you'll see. You have to keep in mind that all of our things that we do, all of our adding, subtracting, multiplying, dividing, reducing, all of that stuff, you still use all of the principles that you've learned in baby math, okay? In 5th grade, 4th grade, 7th grade, all of those principles we used with fractions. We're still using, nothing's changing here, okay? We still need to find common denominators when we add. We still need to reduce. When we multiply, we flip the second one when we divide, we flip the second one and we multiply. Things like that. All of the things that you've learned previously, all of it stays the same, okay? The next thing I want to talk about right here, if you look there, it says you cannot have 0 in the denominator. It is not possible in math. If you try that on your calculator, it is going to say something like math error, syntax error, undefined. Your calculator is going to tell you you can't do it. So that's important here because there's some things that we need to rule out when we're doing these. We need to say, okay, maybe you could have any x could equal any number except for x cannot equal 3, for example. Why not? Because if x equals 3, let me show you an example here. Let's say that we have x minus 3, and that's the denominator. Let's say the numerator is 1. If x equals 3, so if we say 3 minus 3 equals 0, that means that 1 over 0, and we cannot have that. We cannot have 1 as the denominator. So in this case, x could never equal 3. If x equals 3, then it is math error or it is undefined. So how can we find out what values are excluded? Check out this little chart that I have here. It says steps to finding excluded values for x. Number 1, set the denominator equal to 0. So let's go back to this x minus 3. So what we're going to do is we're going to set the denominator equal to 0. What does that mean? Well, x minus 3 equals 0. Set it equal to 0. Okay. Step number 2, solve for x. So we're going to move the 3 to the other side, and we're going to find out that x equals 3. Now, I want you to see something here. Step number 3 says state the excluded value by saying x cannot equal 3. Now, I want to show you a new sign. This is equals, right? We've been using that for years. If you put a slash mark like that through there, you are saying x cannot equal. So if you will write it like this, either using words x cannot equal or using the symbol x cannot equal 3. What are you telling me when you say that? You're saying that all of the other values are possible. Okay, so what if we say x equals 4? Well, 4 minus 3 equals, 1. So 1 over 1 equals 1. That gives us a solution. The only one that doesn't give us a solution is this one right here. That is the one that it cannot equal. So it's kind of funny in a way. It's like the answer is not the answer. So you get it, you set it equal to 0, but then it doesn't equal 0. It can't equal 3. So the answer is the not answer in a way. It's kind of weird, right? But that's what we're going to be doing here in this section. All right, here's one. Let's practice on this one and see what happens. You might say, well, what about the numerator? Okay, I didn't say anything about the numerator. We're going to leave the numerator alone. 0 can be in the numerator. We're going to talk about that in just a second, but 0 can be in the numerator. But we're just going to leave the numerator alone for a second, so just don't touch that. Let's come over here to the denominator, and let's say 3x minus 5 equals 0. That was step 1, right? Set the denominator equal to 0. Step number 2, solve for x. So you know how to solve for x. We're going to do plus 5 to both sides. It's going to cancel. We're going to get 3x equals 5. We're going to divide both sides by 3, and we're going to get x cannot equal 5 over 3. So we could put anything we wanted in there except for 5 over 3. Any value, any other value will work. 5 over 3 will not work. All right, let's try the next one. So we have x minus 3. That's the numerator. We're going to leave that alone. Let's not touch the numerator. Let's come down here to the denominator, and we're going to set it equal to 0. And then we're just going to solve. That's step number 2. So in this one, you might say, well, how do I solve that? Well, you're forgetting the factoring chapter. You're forgetting the how to solve quadratic equation chapter. Okay, how do you solve quadratics? We factor. Or we use the quadratic formula. Or we complete the square. Or we extract the root. We have 4 different ways to solve these. Remember what I've said multiple times. You can't forget the things in previous chapters. If you forget the things from previous chapters, then you're going to be in trouble. So, yeah, just keep working hard. All right, here we go. So what do we want to do? X and x. We're factoring. And then we're going to factor, well, there's nothing out here, so we have to factor that, but we're going to factor the 6. So we have a 1 times 6 and a 2 times 3. You're going to look here, and you're going to try to figure out which one. So we're going to use a plus plus, because that's our signs, plus plus. And we're going to have to use those, the 2 and the 3, and that's going to give us our 5. You do outers, and, oops, 2 and the 3, not 2 and a 5. 2 and a 3, there we go. And you do the outers, and you get 3x. You do the inners, you get 2x, you add them, and you get 5x. So there is our answer, not really, okay? What do we have to do? We had to set it equal to 0. So what should you do now? You should set both factors equal to 0. This one's actually going to have 2 things that x cannot equal. So subtract 2 to both sides, and we're going to get x cannot equal -2. That's 1. And then we're going to move the 3 over, and we're going to get x also cannot equal -3. That would be the 2 solutions for that one. If you put either -2 or -3 into this, you are going to end up with 0 in the denominator, and you are going to get it undefined. Okay, next thing that we need to talk about is on page number 408, page 408. You see right down there at the bottom of the page, it says zeros and rational functions, and it's got like a little box there. This is the easiest way for you to remember it. If 0 is in the denominator, it's undefined. If 0 is in the numerator, then it equals 0, and it's okay. If 0 is in the numerator, it's fine. I talked about that just a second ago, and I said, well, what if 0 is in the numerator? Well, you know what? Then it just is 0. It equals 0. Because, like, if you said, 0 divided by 6, if we had that, if we actually did that problem, how many times does 0 go into 6? Well, it goes 0 times. And so the answer is just 0 to that problem. But with the undefined, you can't divide something 0 times. Like, for instance, I can't say, what is 6 divided by 0? I mean, we're not dividing it. It's almost like that's not a thing because you can't divide something by 0. You can't divide it 0 times. Okay? So if you want to divide something into 6 parts and you want to divide it 0 times, you can't do it. It's not going to work. So that's what we call undefined. So that is important that you understand that in here in this first lesson. Set the denominator equal to 0. Let's go back to these steps real quick. Set the denominator equal to 0. Solve for x. State that the excluded value by saying x cannot equal whatever you get. All right? Well, hope you learned something there. That's all I've got for you. A little bit of a shorter lesson. I know you like short lessons, so that's good. All right. Well, we'll see you later. Have a good one. Bye-bye.